Alright, Mr. Hong here with another review video. We're talking about Unit 3, Systems of Linear Equations. So much fun. So remember that systems of linear equations and inequalities, what this is talking about really is talking about getting an order pair. It's like when two lines cross, if I have a black line and I have like this blue line, what I'm asking you to find is the intersection or a location. So that location is really talking about an order pair. Like for example, 3, 2. If this is like a graph right here, this is X, this is Y. And yeah, that would be like an order pair. And this point right here would be 3, 2. So that's our goal. If it's an inequality, know that if it's a graph like this, and I have two lines, and let's say that this is downwards, so I would do something like this. And my blue line is like this. And let's say I shade upwards. Wherever both colors are is my solution. So like where it's green, kind of like here to, I shouldn't really use that color. If it's like this red area, it would be my solution. Well, it would be like shaded all of this. This would be like my solution. I use parts of both of my line to get my solution for my inequalities. So this is my solution. So when we talk about these problems, we have to figure out what x is equal to and what y is equal to in a form of an order pair. We have to talk about the location. So let's look at number 2. I will be doing the evens so that you can try by yourself the odds. So what is the solutions, which is an order pair of the system equations below by elimination. So know that this is equation A plus equation B. Oh my goodness. Plus equation B. So if this is A and this is B, what can I do to add them together to get rid of an equation? Know that I can multiply this whole thing by -2 to make my y into, well, first let's do this, -12x plus 4y is equal to -4. So whenever I do this, and I add, because this is my equation, this is still equation A. All I did was multiply -2 to everything, the left and the right. So this statement is still true. But if I add them, look what happens. 12 minus 12 is 0. -4 plus 4 is 0. And what happens is that this right here is just really 0 is equal to -4. And that statement right here, this is false. So really my answer is nothing. My answer is no solution. And it's important that you understand that concept. If nothing works, nothing I plug in is allowing me to make this statement right here true. For both of my x's have to, or my x's have to be for both equations, and my y's have to be for both of my equations. So let's try this bottom one right here. What is the solution to the systems of equations below by elimination? So I still have to do A plus B, or equation A I'm gonna use two different colors. I want to use black for my operations. Where's my cursor? I want to use equation A as blue and equation B as green. So let's see. I want to get rid of a variable whenever I add them together. So I can really just add these together. So really this becomes 0x, which is my goal, right? To get rid of a variable. 2 minus 3 is 5y. And a 9 plus 16 is 25. So y is equal to 5. Nice. I have half of my solution already. Because I'm looking for my x now. So I can just plug it in. And I can choose to plug into either equation A or equation B. It doesn't matter which one. Because either way it's going to be true. I'm going to choose the equation A. So equation A is 4x plus 2y is equal to 9. I just copy and pasted it from my question here. I gotta replace this y with a 5. So let me just put this 5 in parentheses. Whenever you substitute something, you should always put it in parentheses. I wanted this blue. Okay, there we go. Alright, so now I can simplify this, as I can multiply this and that. So 4x plus 10 is equal to 9. Then I subtract by 10 on both sides. That means that 4x is going to equal negative 1. I divide by 4. So x is equal to negative 1 over 4. So that means that my solution is going to be like this. And let's say, I want to make sure that's right. Like, you know, like on the test, you only have one try, so might as well get it right, right? And check it. So you can always build a matrix off of it. So what you can do is I can build a matrix and just make it look like something like this. This would be my x, this would be my y, and this would be like my number. Like so. So what's wrong with this is that nothing wrong with it. So it becomes 4, 2, 9, negative 4, 3, 16. Then I would put RREF, or reduced row echelon form, equation A. Nice. Negative 0.25 is negative 1/4. And then my y is 5. So perfect. I did this correctly. Number 6. So John wants to eat, he wants to go out to eat. He knows that he wants to eat burgers and fries. A man has good taste. He knows that he wants no more than 5 items. Oh, he's a big boy. A burger costs $3.50 and order fries costs $1.25. He does not want to spend more than $15. Write him a system of inequalities that represent the situation. So we really need to talk about the themes here. And I'm going to be representing equation A and equation B with the according colors. So equation A, let's see, the first thing that he talked about was the items. He doesn't want to buy no more than 5 items. So I'm just going to write 5 here. So the items that he's talking about is burgers, which I will write as X. And Y is your fries. So if we're talking about just item itself, we're just talking about x's and y's. We're not talking about how many y's or how many x's. We're just talking about the type of item. So there's only two types of items, right? And he wants no more than 5 items. So he could have 5 items, but could he have 6? No. So what if, example, my x plus y is equal to 6, as in like this becomes 6. So if I have 6 versus 5, this wouldn't work out, right? I want something smaller. So this would have to be, this wouldn't work. I would have to be like 4. So if I put 4 and 5, the inequality would face this way. And I can also make the statement true by putting an equal sign below this. Because of no more. No more means I can have it equal to 5 if I want to. But for that example, I was just like, meh. You're fine. So the other thing he's talking about is money, which I will talk about in green, or right in green. So he's talking about money, and he's talking about the quantity of price. So a burger costs $3.50, and order fries is $1.25. He does not want to spend more than $15. So if $15 is his budget, can he spend $16? No, he can't. So what he really could do, or my inequality has to face my 15. It has to. But what about the association for price? Or like, how do I represent this piece of information algebraically? So I know that I have x's and y's, and I know that my cost is going to be both my fries and my burgers. I know that a burger costs $3.50 and fries cost $1.25. I ran out of space, so this will have to do. Nice. Write a system of inequalities that represent the situation. So I want to write here, the question was really write equations that is told in this story. As in, do not solve. This is really actually my final answer. This is actually my final answer right here. I just asked you for the equations. Nice. Problem 8. Now it gets a little bit spicier. So we have Amanda, Benny, and Cynthia, and their siblings. Amanda is the youngest, and Cynthia is the oldest. The sum of the ages of all 3 friends should be all 3 siblings. Where's my cursor? There it is. Why does it keep doing that? All 3 siblings are 56. So let's just stop here and let's just say A, B, and C are Amanda, Benny, and Cynthia. So I know that my equation A is talking about the sum of all their ages. So I know that A plus B plus C, which is Amanda, Benny, and Cynthia, they are equal to 56. The sentence told me so right here, using my literature and my English skills. Amanda's age is 10 more than a third of Cynthia's age. So if Cynthia's age is this, and this is Amanda, how do you represent the 10 more. So let's say, for example, Cynthia is 5. That means that, let's use 6, just because it'll be a cleaner number. So if I did 6 divided by 3 is equal to a number, so this is 2, and I want Amanda to be 10 more than this. So that would have to be 12. So if I subtract 10 on this side, then I would have to subtract 10 from my equation. So really, equation B would be C divided by 3 plus, not plus, sorry, minus 10 is equal to A. And then equation C. Let's read this last part. The difference between Benny's and Amanda's age is 3. So Benny minus Amanda is equal to 3. The word difference is talking about, like in like an example in real world, if I say that Mr. Hong is 200 pounds, which is not true, and let's say his sister is 110 pounds, what is the difference between my weight, or my fictional weight, and my sister's fictional weight? That would be 90 pounds. I would take the difference, which is subtracting the two weights together. Get out of here. So the difference is 3. So write a system of equations that could use to determine the ages of all 3 friends. So once again, I'm looking at the story and I'm writing just the equations. It's not asking me to solve. Just like your 3.5 homework, you had some questions about representing a story and making it into algebraic equations. This is super important when you want to use matrices. An athlete can perform 10 high jumps or 25 squats. So let x be the number of the number of high jump sets, and let y be the number of squat sets. So x is, I'll write this in black, x is equal to sets of high jumps, and let y equal to sets of squats. The athlete can do up to 20 sets of either workouts, or do up to 180 reps in total. So write the system of inequalities that represent the function. So the number of sets that he can do is 20. So let's do the easy one first. A, and this is 20, and I can do up to 20, so I can't do any more. So this is my highest value. I can also do 20, so this is why I would have an equal to sign below it, or including it in my inequality. And the sets are really just representing x and y. This is the number of sets of high jumps, and this is the sets of squats. But let's look at B. Equation B is talking about he can do up to 180 reps. Reps are kind of like just the action itself, so 1 squat and 1 push-up. And he can do up to the same verbiage as up to 20 sets. So the inequality is really going to be facing the same way if we use logic. How many sets or how many reps does he do per set of high jumps? He does 10 high jumps per set. And he does 25 squats per set, and this is a rep. So this is a representation of the story above. The graphing question. And this is really important. You need to know how to graph, or you need to identify which graph is correct. And you can really do this in multiple ways. You can either graph them in Desmos and then you can figure it out yourself, or you can graph it by hand. And I will show you graphing it by hand. But what's weird about this part right here, the second equation, is that I need to make it look like this. Y equals mx plus b. Because if I have it like this, there's no place for me to start. So what I need to do is, well, I could just move the y and then subtract or move everything else away from this. So x minus 5 is less than y. And a lot of people don't really like the way it looks like this, so I'm going to rewrite it above. So if this is equation A, then equation B will be here. And this is equation B. And it's going to be y, the inequality is still facing the y. X minus 5. Nice! Now I can graph this. And I'm going to be associating my graph, or my equation, by color. So this is blue. This is 4x minus 2. And if you didn't know how to graph in linear equations, you're in trouble. You go down 2, because this is my y-intercept. And then I go, if I have slope as 4, this is the same as 4 over 1, rise over run. So I go up 4, 1, 2, 3, 4, 1. So this is my next point. 1, 2, 3, 4, 1. And I know that my line, or my inequality, has no equal to, so this would be a dashed line. 1, 1, 2, 3, 4. And look at that. It makes a straight line. If my drawing was perfect, then my line would be perfect. At least straight. But it's not. And yours doesn't have to either. But it just has to be somewhere in the vicinity of it, or something similar to it. So this will be green. X minus 5. So let's do it. So this is 2, 3, 4, 5. And then this slope is a positive 1, so I just go, you see how like this is the next spot, and it just goes diagonally. So I can draw a dashed line again. Boop, 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 boop. Another dashed line like so. And now I have to talk about shading. If y is greater than equation, shade upwards. And if y is less than equation, you shade downwards. So let's start with equation B, just because I'm in green. If y is greater than the equation, like so, I have to shade upwards. As in, I'm gonna just choose a random point in my line, and I'm just gonna draw a straight up arrow. And that really means that I'm gonna shade this. Stop it. There we go. And I can really just shade this like so. I'm just trying to make this neat because these are your notes. Yes, and if I don't get all the parts of the graph, people will be like, Mr. Hong, your video made me so mad. So, there you go. Do you see how much I sacrificed for you? Perfect. So this is my solution so far, but only half of it. Let's look at this one. The blue graph is talking about y is greater than equation. So I use this one again. So I choose a random point in my blue graph. I can choose here, I can choose here, wherever. Anywhere above my line without crossing it is my solution. So I'm going to just use this nice pink color. And I'm going to include this little bit right here because we're just talking about the blue line. So what happens with the highlighter is that whenever I mix them, it turns into a different color. And I kind of like that because it kind of shows, well, it doesn't kind of show, it shows exactly where my two colors meet. Like so. I'll get this part right here. Don't worry. So this black area is really my solution. Both colors. Oh my god. Colors are shaded. Nice. Both colors shaded is the place where my solution is. So on the test, which I've seen, your answer choices will present pictures of grass as your answer choices, and you're gonna have to choose the correct one. Pretty simple. Another question, I'm not going to do this problem just because it's so repetitive. Just know that you do have to get this into, you have to get both of these equations, y equals mx plus b, then you just graph it. So let's look at this. If a point, which is, an order pair, is the solution of the system below, what is the minimum possible b? So you see how both these things are set equal to y? Oh. Really what I can do is say that negative 20x is equal to 100x plus 480. And then I just solve it like a regular problem. So I add my 20x and I subtract 480. And what that would be is plus 20x. So this is 120x or 120x, and this is, well, I have to subtract 480. So this is negative 480. And if I divide 120 from both sides to get my x alone, right? Then this would be what? 4 or negative 4. X equals, I'm going to write it on top. X equals negative 4. But that's not my answer. My answer is talking me to my possible b. But in this case, b is right here. So really, I'm looking for y. Because I know in an ordered pair, this is really x comma y. I found x. I need to find y. So it will look like this. Y is greater than or equal to negative 20 times negative 4. So y has to be greater than or less than or greater than or equal to 100. So what is the minimum possible y value? If I say y is greater than or equal to 100, really my lowest value, which is also known as minimum, is 100. So this is your final answer right here. Boop. And let's see if that's true. Let's go to Desmos again. And I'll go to the graphing calculator and I type these in. Y is less, not that one. This one, negative 20x. And the next one, y is greater than or equal to 100 x plus 480. So if I go all the way up for my solution, right here where it crosses, this is actually where my minimum Y value would be. 80. Why is it 80? Oh my god. Mr. Hong did it. Uh-oh. This right here isn't positive 100. This is positive 80. So this right here is positive 80. Whoops. You're fine though. I don't want to remake the whole video, so just a quick correction. Alright, only one more to go. The Dallas Cowboys sell different types of seats. Nosebleeds, which is like the highest, like, so if you're at like the Cowboys game, I guess that question doesn't age well because I wrote this last year, but the nosebleeds is like the highest of the stadium, so you're not going to be able to see most things. Like you can see like a bird's eye view, like super up. Standard, which is kind of like you're like in the middle, and then VIP is like you are so close to the ground. Nosebleeds cost $300, standards cost $500, and the VIP costs $700. We made these numbers easy. It's usually not that simple because you have to talk about tax and stuff, but this is just a hypothetical. Jerry Jones, who is the owner of the Cowboys, made $700 in one game. He loves money. In that game, the nosebleeds sold 50 times the amount of the tickets for VIP. The standard seats made 40 times as much money as the nosebleeds. How many VIP tickets did the Cowboys sell? Wow. So, what a great story about Jerry Jones and the Cowboys, the Dallas Cowboys. If you didn't know, Jerry Jones, he loves money. Jerry Jones. This guy right here. This guy right here, he owns the Cowboys and he loves money. So really, I need to start off by writing some equations of representing the situation. So I have A, B, and C. And I can't really talk about the quantity of tickets sold because they didn't tell me, but they told me two special equations, or two special situations, or conditions. The first one's easy. I know that I sold the money $615,700. I did not give myself enough space, so let me rewrite that like to here. 615,700. So nosebleeds, this is going to be X, this is going to be Y, standards are Y, and then VIP is Z. So nosebleeds costed 300, standards costed 500, VIPs costed $700 per ticket. Ooh, I use X again. Nice. Okay. So my other special case is that in the game that he made that much money, the nosebleed tickets sold 50 times the amount of tickets of VIP. So let's say I have 5 VIP tickets. That means that I would have to have 5 times 250 tickets, right? Or not 250, what am I doing? Times 50 tickets to make it equal 250. This is actually my equation right here. Remember, this is talking about VIPs, which is Z. So 50 times Z is equal to the number of tickets, and this would be my nosebleeds or my X's. So this is equal to X. The standard seats made 40 times the amount of money as the nosebleeds. So the nosebleeds costed $30 each. So 30x. And standard seats made 40 times as much money. So really, I multiply the other. So standard seats, the other thing they're talking about besides the standards, which is nosebleeds, I would multiply this by 40 to get my standard, which is my 40x, or not 40x. Did I say 30? Whoops, I meant 300. And this would equal 500y. So 500y is equal to 40 times 300x. I don't like how that looks. And I can really simplify this. So I'm going to write it again nicely to make it 12. And then just add the zeros. I have 1, 2, 3 zeros. 1, 2, 3 zeros. Hey! The standard tickets did well. So, how many VIP tickets did the Cowboys sell? So, I'm not asking you for a coordinate. I'm not asking you for X, Y, and Z. I'm only asking you for my VIP. And I told you that VIP is your variable Z. So, the way that we can really do this is we can, well, we could make it as a matrix. So I'm going to show you how to do it as a matrix because it would make more sense. This color stuff is getting weird, but let's look at equation A. Equation A, if I write it in a matrix, which I will write here very smallly, I can write this in a matrix. I can do 300, 500, 700, and then this right here, I ran out of space, is 615700. So that's true. I can do that. But let's look at equation B. Equation B is 50z is equal to x. We're not talking about the money. We're talking about quantity for question B. But what's wrong is that my matrix equation needs to be x plus y plus z is equal to a number. So I need to move this x over here. And the way that I move that is by subtracting on both sides by x. So negative x plus 50z is equal to 0 because there's nothing left here, right? But what's missing is my y, and I need to put a placeholder, as we learned in class, 0y. If I have no y's, I have 0 y's. So I pretty much just gave y a numerical value of 0. So now I can write my next equation, which is negative 1, 0, 50, 0. Nice. And the last one, which is equation C, which I'll write in blue, I guess, is 500y is equal to 12,000x. And the same thing goes. I need to move this to the left side, so I need to subtract by 12,000x. So this would be negative 12,000 x plus 500y, and I don't have any z's in this equation, right? So I would write 0 z's is equal to, I don't have a numerical value, so this is also 0. So this is 500, this is 0, and this is 0. Nice. Easy peasy, lemon squeezy, you are ready for the testes. That came out very badly. Don't report me. So 300, 500, I'm gonna move that like that. Okay. 700, 615700, negative 1, 0, 50, 0. Negative 12,500, 0, 0. So let's see if this works. Reduced row echelon form, equation B. Nice. So it looks like regular whole numbers, and that's a good sign in regular. In pre-AP, you don't know. But in regular, we can assume that this looks pretty good. So x is equal to 50. Y is equal to 1200. And z is equal to 1. So this right here is my answer because I'm asking you for the VIP. What the? Stop that. I'm asking you for the VIP tickets. The VIP tickets representation is Z. I stated so right here. There you go. Perfect. So easy. So the hard part of this problem isn't the math. The math is easy. The math right here, this is algebra 1 right here. This is algebra 1 right here. But this part right here, well, this is also considered algebra 1 times 3 times. You have to be able to create 3 equations from 1 prompt. So really this problem is algebra 1, but the fact that we're doing A, B, and or X, Y, and Z, 3 variables, is algebra 2. And you right now are in algebra 2. So that's why we give you this problem. Expect a question not exactly like this, but very similar to this on your test. Number 20. Find the ordered triplets, which is pretty much just an ordered pair, but with X, Y, Z, in the solution of the following systems of equations. So we used matrix for this one. We cheated, kind of. I didn't have a lot of space. I just want to do a matrix, but for this one, I want to use elimination for this. And the reason why elimination seems very attractive to me in this problem is because I have a z, I have a negative z, I have a negative z, and a positive z. So I will say this is A, this is B, and this is equation C, and I would say that this is my easiest. Actually, that's not true. It is true. It is my easiest, or is going to be my most common, because this is -1, this is -1, this is +1. So equation C, I'm going to be using twice. So 2x plus 10y plus z is equal to 3. I'm going to write that twice. Equation B is 5x plus 10y minus z is equal to 2. And equation A, which is x minus 5y minus z is equal to -8. And the reason why I want to use equation C is because when I use elimination, where I'm using here, this is called elimination, for this and for this, I'm going to be adding them. And what happens is that if I add both equations separately together, it doesn't scroll the way that I want it. There you go. Like so. When I add these two together, this is 7x, this is 20y, but what happens is 1z subtracted by another z is 0z, as in this cancels. And this is equal to 5. Let's see this one. Let's see equation CA. So this is 3x, this is plus 5y, because 10 plus -5, or 10 minus 5 is 5, and the y's follow. But this also cancels too. And this is equal to -5. Nice. So now I have equation, I couldn't find my cursor. There it is. This is equation D and this is equation E. So I need to get rid of one more equation, or one more variable. by using elimination again. So I have equation D, which is 7x plus 20y is equal to 5. Equation E, however, has 3x plus 5y is equal to negative 5. But I want to make this into the opposite sign. Same value as my other y. So I want to make this become negative 20y. So what I thought was 5y times something is equal to negative 20y. And this something right here is negative 4. So what happened was, really, I multiplied this. So what happened? I multiplied everything here by negative 4. And I just drew that in a different color to really show you that. So really, if I multiply everything here by negative 4, I should be like this, and like this, and like that. So 3 things I'm multiplying by negative 4. And I've already done this one, right? So this one's done. Negative 4 times 3 is negative 12x. I guess I should write that in black. Negative 12x, and this is equal to positive 20. So this is still equation E. I just made my numbers bigger, but the statement is still true. So let's bring back equation D that hasn't been tainted or touched or manipulated algebraically. And now I can add these two. And look what happens when I add them. My x is good. This becomes negative 5x, or negative 12 plus 7 is negative 5. This cancels, and this is equal to 15. So x is equal to negative 3, because if I divide negative 5 on both sides, bada bing, bada boom. So far, I'm pretty good right now. Like, I should feel pretty good, because getting my first variable is the hardest. So this is negative 3. So what I want to do with this negative 3 right here, which I guess I'll highlight because this is important, is I want to plug this into dog or equation elephant. I'm going to use equation E just because it's easier. 3x plus 5y is equal to negative 5. And my goal is to get y equals to a number or something. And I know what this x is. This x is this. So this x right here is the same as this below. Or, yeah, I guess it is below. But I can substitute it. Or I can do 3 times. So if this is negative 3 right here, this is also negative 3. Plus 5y is equal to negative 5. So this becomes negative 9 plus 5y is equal to negative 5. I do plus 9 plus 9. 5y is equal to negative 5. Not negative 5, sorry. Positive 4. So y is equal to 4 over 5. Let me see if that's true real quick. Let me look at my notes. Alright, Mr. Hong is back, and he found the mistake. All this right here doesn't work. And the reason why, if you spot it, good for you. But if not, please forgive me. But what happened right here was my mistake. This shouldn't be 15. This really should be 20 plus 5 is 25. Is equal to negative 5x. So when I divide negative 5 on both sides, x is equal to negative 5. So this right here is also incorrect. No wonder, I sniffed something incorrect. So now that what is this box doing here? What? Okay, whatever. So if I do equation E again, 3x plus 5y is equal to negative 5, I can do 3, and I can substitute this negative 5, which is right here, to here. Because negative 5 is x, this x and this x is the same x, plus 5y is equal to negative 5. Okay, now it makes more sense. Negative 15 plus 5y is equal to negative 5. I add 15 on both sides. 5y is equal to 10. So y is equal to positive 2. Thank the Lord. It's a more easier number. And now, I just choose A, B, and C. And yes, I said that we're going to use equation C all the time, but we're going to do equation A because the coefficients are smaller. So equation A, I'm going to zoom out just so I can copy this correctly. This is x minus 5y minus z is equal to negative 8, okay? But I know what this is. This negative 5 is here. This 2 is here. So I can rewrite this as negative 5 minus 5 times, I guess I'll write it blue. Negative, or positive 2. What am I doing? Minus z is equal to negative 8. So I'm going to do this operation first, which is multiplying. So negative 5 minus 10 minus z is equal to negative 8. So this is negative 15 minus z is equal to negative 8. I add 15 on both sides. So negative z is equal to positive 7. So z has to equal negative 7. Nice. Let's see if that's true. Ah, perfect. So and let's say, for example, you try to do this problem doing elimination substitution, and you know, I might not. Who knows? You might be expected to do this. But the way that you can check your answer, even if you do elimination or substitution, you can write a matrix. Nothing is stopping you from writing a matrix. It's just that I want to see work if I ask you to do elimination or substitution in the problem, if I ask for it specifically. So if I type this in, nice. Negative 5 to negative 7. Negative 5 to negative 7. Perfect. Nice. So that pretty much concludes our review video. I saved the left half that you can do. If you turn it in, or if you show me a picture, you will receive extra credit. But other than that, Mr. Hong out. Good luck on your test, and stay safe and stay healthy and wash your hands. Deuces.